Assalamualaikum warahmatullahi wabarakatuh. Today we would like to present about polymerization methods for polyethylene production. Polyethylene is a versatile and widely used thermoplastic polymer made from the polymerization of ethylene gas. It is known for its lightweight, durability and chemical resistance. It is used in various forms such as low density polyethylene for plastic bags, high density polyethylene for containers and pipes, and ultra high molecular weight polyethylene for medical implants. Despite its advantages, polyethylene's non-biodegradability poses environmental challenges, highlighting the importance of recycling and sustainable alternatives. This is our group member who are going to present today. Let's jump to the video.
The first polymerization method for polyethylene is bulk polymerization. The bulk polymerization method for polyethylene is bulk polymerization involves polymerizing monomers in the absence of any solvent or dispersing medium. For polyethylene, this process uses ethylene gas as the monomer and operates under controlled temperature and pressure conditions. Catalysts like Ziegler, Nata or metallocaine catalysts are typically used to facilitate polymerization, which occurs in a single-phase reaction system. Key operating parameters such as temperature 100 to 300 Celsius and pressure to 10 to 300 atmosphere vary depending on the specific type of polyethylene. Low density polyethylene, high density polyethylene, or linear low density polyethylene will produce. The fundamental principles. The fundamental principles of bulk polymerization for PE is high monomer concentration. Polymerization occurs with pure ethylene or mixture with minimal additive, maximizing the rate of monomer conversion. The second principle is catalyst action. Catalysts initiate the polymerization reaction by breaking ethylene's double bonds, allowing chain growth. And the third principle is thermal and pressure control. Reaction conditions are carefully managed to ensure uniform polymers properties and to prevent overheating due to exothermic reaction heat. And the final principles are molecular weight regulation. Chain transfer agents such as hydrogen may be used to control molecular weight and achieve desired polymer properties. And there's the advantage and disadvantage of bulk polymerization. And the first advantage of bulk polymerization is high polymer purity. The absence of solvents minimize contamination and produce polymers of high purity. And it's also efficient monomer utilization. Minimal loss of monomer as it is directly converted into polymer. And the third is simple process design. Few operational steps since no solvent recovery is required. And the final advantage is environmentally friendly. Eliminates the need for solvent disposal and reduce environmental hazards. And the disadvantage for bulk polymerization is the heat removal challenge. Exothermic heat from polymerization is difficult to dissipate without solvents, risky runaway reaction. And the second is high energy requirement. Operating at elevated pressures and temperature requires significant energy input. And the third disadvantage is limited control of morphology. Compared to suspension or solution polymerization, bulk methods provide less flexibility in controlling the final polymer microstructure. And the final disadvantage is catalyst sensitivity. Catalysts must be extremely effective and stable under bulk conditions. And these are the products and applications for bulk polymerization for polyethylene. The first is high density polyethylene HDPE, and then the application is pipes, containers, household goods, and industrial packaging. The second is low density polyethylene LDPE. Application is plastic bags, cling films, and flexible packaging. And the third one is linear low density polyethylene LLDPE. And the application is stretch films, agricultural films, and injection molded products.
So, I will explain about the solution polymerization method for the production of polyethylene. Firstly, reaction medium. The polymerization takes place in a hydrocarbon solvent such as hexane, heptane, and cyclohexane. Then, molecular weight control. There are two of molecular weight control, that is temperature adjustment and hydrogen addition. Temperature adjustment is high temperature can cause reduced molecular weight, and hydrogen addition act as a chain transfer agent and can reduce molecular weight. Next, applications. Use in high-performance films, pipes, and injection molds products. Next, I will explain the key principle and key condition of solution polymerization. Firstly, solubility of components. Both of monomer and the resulting polymer must be soluble in the solvent used. The solvent acts as a medium to dissolve, reactant, and facilitates the reaction. Secondly, catalyst system. The reaction is typically catalyzed using systems such as Ziegler-Natta catalyst for HDPE, and the catalyst ensure high efficiency, control molecular weight, and selective polymerization. Furthermore, the advantages and disadvantages of using solution polymerization for PE. The advantage is precise molecular weight control, recyclability of solvent, and high purify of product. The disadvantages is high energy requirement, high operating costs, and complexity of handling. Moreover, this is the example of provide real-world example of product and application involving solution polymerization of PE. Firstly, linear low density polyethylene (LLDPE), plastic films, stretch films used in food packaging, agricultural films, and pallet wrapping. Cable isolation (LLDPE) is used in electrical cable for its flexibility and dielectric properties. Secondly, high density polyethylene (HDPE), pipe and fittings used in water supply system, gas pipelines, and system due to its pressure resistance. Fuel tanks, automotive fuel tanks, and chemical storage container for their corrosion resistance. Next, agricultural use. Greenhouse films (LLDPE) films are used in agricultural covers for durability and UV resistance.
Next, I will talk about emulsion polymerization. By definition, emulsion polymerization is a free radical polymerization technique in which a monomer is polymerized in aqueous medium using emulsifiers and initiator to stabilize the reaction. The resulting polymer forms as the fine colloidal particles suspended in water creating a polymer. For this case, we want to produce a polyethylene, so we need to choose the monomer such as ethylene. But how to produce polyethylene is the same. First step, we need to focus on monomer selection. For example, we need to produce polyethylene, so we choose a monomer ethylene. Since ethylene is gaseous at room temperature, it's typically compressed into a liquid form and absorbed into water phase under controlled condition. For the next step is step 2, water phase and surfactant. Water acts as the continuous fill, while a surfactant helps emulsify the ethylene monomer into droplets. The next step is step 3, initiator. A free radical initiator such as a potassium persulfate is used to initiate the polymerization reaction. The last step is step 4, polymerization reaction. The polymerization occurs within the monomer droplets as the polymer changes gold. They continue to aggregate, forming particles of polyethylene. These particles are dispersed within the aqueous phase and can be separated, purified, and dried to yield the final product. So, this is an essential principle to form a polyethylene by using emulsion polymerization. Thank you. Let's go for the next.
Boleh pun.
So, same like for the all polymerized reaction, it has advantages and disadvantages. But for this advantages and disadvantages for emulsion polymerization, first we go to advantages. We have 3 advantages why we need to use emulsion polymerization. First is control polymerization. The second is higher reaction rate, and the third is lower reaction temperature. For these advantages, we have 2. First, the complex process, and the second, in limitation with gaseous monomer. Thank you.
For polyethylene production, the ethylene monomer is dispersed as droplets in an inert liquid phase. A stabilizer or dispersant is added to maintain the suspension of monomer droplets, which serve as mini reactors where polymerization occurs. The resulting polymer forms as spherical particles that can be easily separated from the water. To carry out suspension polymerization for polyethylene, the water is usually taken as the solvent as it is inexpensive, environmentally clean, and also a better transfer heat medium. Next, the initiator is added. Initiator is the compound that decomposes to form the free radicals, which then start the polymerization process. However, since polyethylene is typically produced via chain growth polymerization methods involving catalysts rather than free radicals, suspension polymerization for PE uses catalysts rather than conventional radical initiators. The common suspending agent for other polymers is PVA, polyvinyl alcohol, but for polyethylene we use titanium tetrachloride because it is a Ziegler-Natta catalyst. Polyethylene production typically relies on the coordination polymerization catalyzed by Ziegler-Natta or metallocane systems, which facilitate precise control over the polymer chain's growth and branching.
Next, the agitator will rotate at a specific speed. This will help monomeric units to form a ring-shaped polymeric units. The polymeric unit is depend on the agitator speed.
This is the advantages of using suspension polymerization methods for polyethylene. First, it is a good heat control. The water phase provides excellent heat dissipation, preventing hot spots and ensuring uniform polymerization. Second, it is an ease of handling. The bead-like polymer products are easy to filter, wash and dry. Next, it is high purity. The process minimizes the contamination, producing relatively clean polymers. And last but not least, it is suitable for large-scale operations with consistent product quality. However, there are some disadvantages of using suspension polymerization methods. First, it requires water treatment. The additional steps for separating water and recycling it, increasing the operational complexity. Second, it has a limited application. It is not ideal for producing very high molecular weight polyethylene or specific grades requiring different reaction conditions. And last but not least, equipment costs. It requires specialized reactors and equipment for maintaining suspension stability and effective mixing. Here are some examples of the suspension polymerization methods application in the world. First, it is used for plastics and polymer production. For instance, the production of polystyrene, the production of polyvinyl chloride (PVC), and the production of polymethyl metachloride (PMMA). Next, it is used for ion exchange resins. Water treatment beads produced via suspension polymerization are functionalized to remove ions like calcium, magnesium, or heavy metals from water. Chemical processing used in catalysts and separation processes. And last but not least, it is used for coatings and paints. The micro capsules in the polymers formed through the suspension polymerization serve as components in self-healing coatings of time-release paints.
And the next polymerization for polyethylene is gas phase. Gas phase polymerization is a widely used method for producing polyethylene, particularly high-density polyethylene and linear low-density polyethylene. In this process, ethylene gas monomer is polymerized in the gaseous phase with either formaldehyde bed reactor or a steel bed reactor. Catalysts such as Ziegler-Natta, metallocane, or chromium-based catalysts are used to initiate and control the polymerization reaction. The process is conducted under moderate pressure such as 10 to 30 bar and temperature of 70 to 110 C conditions. And then the core principle and condition for gas phase polymerization. The first is monomer supplies. Ethylene gas is continuously fed into the reactor and maintaining a steady concentration. The second is catalyst system. Solid catalysts are used to initiate and sustain polymerization, often supported on inert materials like silica. The third is polymerization environment. The reaction takes place in a formaldehyde or still bed reactor, ensuring even distribution of monomer and catalyst particles. And the fourth is temperature control. The reaction heat is efficiently removed using circulated gas streams, converting hot spots and ensuring consistent polymer properties. And the fifth is polymer recovery. Polymer particles are collected at the bottom of the reactor, while unreacted ethylene is recycled back into the system.
Furthermore, the advantages and disadvantages of gas phase polymerization for PE. Advantages: simplicity of process, low energy consumption, cost efficiency. Disadvantages: heat management challenges, limited processability of co-monomer and catalyst sensitivity. Next, example of products and application that leverage gas phase polymerization for PE. Everyday consumer goods, shopping bags. LLDPE provides strength and flexibility for plastic grocery bags. Trash liners, puncture resistance and stretchable liners for home and industrial use. Next, high density polyethylene HDPE. Containers and drums, industrial drums, jerrycans and chemical storage tanks for durability and leak resistance. Next, linear low density polyethylene LLDPE. Cable insulation, flexible insulation for electrical wire and cables.
Let's discuss all of the methods that has been discussed in this video. According to the table, we can see that the solution polymerization methods is the most expensive methods. This is because it is required to solvent recovery and recycling. Therefore, it is costly and expensive methods to be done for factory or industries. Next, we can see that emulsion polymerization methods is the less purity has a less purity rates. This is because the complex purification needs to be done to remove the surfactant and stabilizers, and also it is limited to specific monomers only. So therefore, the emulsion polymerization did not have the pure polymer compared to the others. Next, we can see that the bulk method is hard to control the heat because the heat management due to the poor heat dissipation. So the heat will affect the polymer product at the end of the polymerization. Next, we can see that the suspension method is uncommon for polyethylene as because the suspension method is usually used for the PVC products. Therefore, because and it is requires separation and drying of the polymer. So it's not common for polyethylene. It is common for type of PVC. And last but not least, we can see that the gas phase methods is the best for polyethylene as it has a gas medium and also a good heat management, high polymer purity, low cost, and applications for high HDPE and LDPE. So gas phase is the best methods compared to all of the methods.
In summary, the production of polyethylene involves diverse polymerization methods, each tailored to specific needs and application. Bulk and gas phase polymerization dominate large-scale production due to their efficiency, while solution, emulsion, and suspension methods serve specialized markets. Understanding these methods is critical for innovation and sustainability in the PE industry, ensuring this vital material continues to meet global demands.
I hope
this video can help you about how to produce polymer polyethylene. That's all from us. Thank you. Sorry for the oral mistake.